cheapest flights within K stops. There are and cities connected by some number of flights. You are given an array of flights. Array flights where flights are is equals to from to and price. Indicates that there is a flight from city from to city to with cost price. You are also given three integers, SRC, DST, and K. Return the cheapest price from SRC to DST with utmost K stops. If there is no such route, return -1. So example 1, we have the visualized image. It says we have n number of cities, so 1, 2, 3, 4. Our flights. So from to we'll have the cost of 100, which is shown over here, and it shows you for every one of these. So we can see that it chooses this path. So we can the K is 1, so we can only stop 1. So boom, 1, and we get to our destination. Well, this one is the cheapest. Going this way, then this way, and this way is the cheapest, but we have to stop 2 times, so it doesn't meet this K over here. So that's why we just choose this one, because that's the cheapest. That only stops 1 time, and it explains it over here. And same concept for this one too. We stop case 1 still. We stop 1 time, then get to a destination. This one you can just go. We don't have to stop here, but it will be much expensive than this. So we end up going with this, and it's 200 instead of 500. So here we can't stop K0, so we just get here, boom. So even though this is more expensive, we can't stop, so it's the only option that we have here. So we can solve this using a Bellman-Ford. We can solve it using a Bellman-Ford algorithm. Oops, why did I spell like this? Bellman-Ford algorithm. So let's hold on. So we need to make our list. So let's make a list to hold price of cheapest cost. So dist is the distance. Or let's just call it cost. Cost, and then put float infinity times n, and then cost SRC will be 0, so the starting cost will be 0. So now let's okay, now let's make a for I in the range. I want to call this underscore for node or vertex in range of so K plus 1 since we're using range. So k plus 1, and then let's make another loop. So for from I to I and price and flights. These are them. From to price. So if cost from I is not float infinity, and cost from I plus the price is less than, forgot to make our temporary list to hold our cost without. So that would be temp equals to cost, and then put everything in it. Boom. So now the temp will be to I. So if it's less than what we do to get to I. So now let's go ahead and let's make temp to I with then be equals to this over here. So cost to I. Oops, cost from I plus the price. So we use this same thing over here. If it meets both of these conditions, this and this, then we take them and update our two. So now let's see. So let's move out of this and make cost will now be updated to the temp once we're out of this loop. And so then now we can just return. Well, let me copy and paste this just so that we are aware what we need, what our goal is, what the goal of the problem is. Return cost and the destination if cost DST is not equals to float or less than float, whichever you want to do. Float else if there's no such route, return -1. So let's see if there's any syntax errors. So we take this from I to I price and flights. From I it's not equals to and that should work. Let's see if it does. it says invalid syntax. So from R in the range of k plus 1 and so from R to Y implies if I from stick space here. Invalid syntax. What is wrong here? So is it the cost? Float infinity times n for R in forgot the simple n in range, and that's it. So the time complexity is equals to so time complexity will be e plus k. So we can only go O of e times k city times the inverse. We can start space complexity is so we're using of n over linear growth in space needed. So now let's submit to see if it's going to pass all cases, and it's been able to pass all cases, and that's it for this problem.